All right, so right now we have for the finding the extrema, we have the first derivative test where we draw our number line, and then we have our second derivative test where we find our critical numbers and then plug in into the second derivative to determine if it's concave up or concave down. So those are two methods that we have for determining a relative max or min. Now, what we're going to do in this section is we're going to think about a completely different situation, a different scenario. The scenario that we're going to think about is if you have a continuous function on a closed interval. So the closed interval is going to be a square bracket that is included in the problem statement. And when you have that closed interval, you are going to have a different process than the first derivative test. So when it is a closed interval, first of all, what does it mean for it to be continuous? It simply means that there's no denominator, there's no square root. Because remember, we talked about how it's continuous on the domain. Closed intervals, again, are only square brackets. So you're looking at no denominators, no square roots on that interval, and a closed interval. If that happens, we are going to have a different process than the first derivative test. And that different process comes from this extreme value theorem that says that if f is continuous on a closed interval, then it actually has an absolute max and an absolute minimum. So this page is just for your information, but I want to just quickly kind of draw a little graphic like kind of summarizing where we're at over here on the next video to kind of summarize the different methods.